In this part, I'm going to look at the idea of making code to avoid the problem of code repetition. And to do that, I'm going to go back to this holding class that we worked on earlier. Just to refresh your memory, we have this holding object that had name, date, shares, and price. And one of the things that we started doing at one point was defining properties. What a property is it's like a managed attribute. Essentially, we were defining price to enforce some type checking. So if we had an instance of a holding, what somebody could do is they could set the price to a float, but if they tried to set the price to a string, it would blow up. And that's great, except that all of this code that I had to write here, incredibly annoying having to do that. So what I'm going to do in this section is actually explore an idea of how to simplify that code using the idea that functions can make other functions. And so to do that, I'm going to leave the holding class up on the other window there, but I'm going to make a new file, something called typed property. What I'm going to try to do is take this property code and generalize it into something that I could reuse over and over and over again. Again, I don't like the idea of having to type this code in all the time I want type checking. So here's the idea that I'm going to do. I'm going to write a function called typed property. And what I'm going to have this function do is take a name and an expected type. The idea on this is that I want to do something like enforce a type on something like price. I want to say, hey, price, you're a float, or shares, you're an int. So that the name is going to be something like shares or price, and the expected type is going to be something like int or float. What I'm going to do in this function is I'm actually going to replicate this code that I'm showing over on the left. Let's look at that code for a second. One of the things that I have over on the left is an underscore attribute, underscore price. That is actually where I'm storing the data. So let's do that. I'm going to say private name is equal to an underscore plus the name. That's the first step. The second step is you will notice that there's a pair of property declarators. There's a getter and there's a setter. We're going to do that. I'm going to declare a property, and I have to put a function here, and this is going to look a little weird, but I have to pick a name for my function. I'm going to pick prop for lack of creativity on my part. The name does not matter. I have to call it something, so I might as well call it prop. What I'm going to do in prop is I'm going to do that get operation. I'm going to recast it in a slightly different form, but I'm going to say, hey, why don't you get at or self private name? Private name is the thing with the underscore. I'm doing the same thing as the get. And then what I'm going to do is attach a setter to this that enforces the type check. So I'm going to do exactly the same code. I'm going to say, well, if this is not an instance of this expected type, keep in mind, I'm generalizing it a little bit, we'll raise a type error. Getting a little bit wide in the editor there. Okay, so we're going to raise a type error. And then if it looks okay, I'll do a setAttr function. So we're going to set the private name to value. Keep in mind, what has happened is the code on the left has been generalized on the right. It's almost exactly the same, except I'm using setAttr and getAttr in a few things. And then what I'm going to do is return prop back. This is kind of the mind-blowing part. I've got a function typed property. It is making a fragment of a class just right there and returning it back. Why would I do that? Well, the reason that I would do that is that this typed property now becomes something that I can reuse in my code. Like I can make declarations like this. I could say shares is equal to typed property shares int, and price is equal to typed property price float. This one line here replaces all of this code that I had to write over on the left. Let's go ahead and give this thing an init function just so I can fill it out and test the code a little bit. So what I've done is I'm sort of using this idea of making code to greatly simplify life for myself over here. Again, I'm thinking in kind of the large, by the way. I'm thinking of the situation where I might have to reuse these properties over and over and over again. By having a little utility function like that, it makes it a lot easier. Okay, so there I'm doing my typed property. What I should be able to do is make a holding object, the same as before, but if I look at something like shares and price, if I put in a bad value, it's going to catch that. That's kind of awesome. It's like, okay, you're making code. I don't have to have the class so complicated. It turns out that I can take this sort of one step further. Let's focus on this a little bit more. One of the things that might happen is I might look at this and say, well, that is still kind of verbose. It's a little bit low level, a little bit cryptic maybe. If I want to, I can run with this idea of making code and alias those operations. One of the things that I could do is define integer as a lambda function. Keep in mind, lambda is another way of making code where this is the same as doing a typed property of name int. What I'm doing is taking a function that takes 2 arguments and kind of reducing it down to a 1 argument function. I'm hiding that detail a little bit. Maybe I do the same thing for strings or something. What I'm doing is taking that typed property function, hiding it behind something that's a little bit simpler, and then all of a sudden I can start writing code like this. Name is string name, shares is integer shared. Like that. Now it's starting to get interesting. It's like we're back to a much sort of simpler formulation of that class. The whole thing that makes that work is the fact that you can have functions make other functions. You almost have to think about it in terms of like macros or something. I mean, you can write Python code that makes other Python code, and you can use that to greatly simplify what you're doing, assuming that you know that you can do this. Let's just make sure that things still enforces type checking. That's one use of closures. We're going to see some other uses of this in some of the later sections. It turns out that this ability to make code like that is an essential part of various sort of meta programming techniques that get used in Python.